Okay, so I'm going to do this one again. I made quite an embarrassing error in the previous one where I found the wrong inverse Laplace transform. Clearly, that was just a silly mistake. Okay, so we're going to take the Laplace transform of the left-hand side, and when we take the Laplace transform of the left-hand side, so let me remind you of a little shortcut. When the initial conditions are 0, on the left-hand side, we're going to have the characteristic polynomial times x of s. So it'll be like this: x of s times s squared minus 2s plus 2. And on the right hand side, well, the Laplace transform of delta of t minus 1 is e to the minus s. And so this tells us that x of s is equal to e to the minus s over s squared minus 2s plus 2. And now there's two things we're going to do. Remember, we want to write this as e to the minus s times something because of the identity up here. Okay, if I have a Laplace transform that is of the form e to the minus cs times f of s, this is equal to uc of t times f of t minus c. So in other words, I just want to find the Laplace transform, or the inverse Laplace transform, of big f of s. Okay, and so over here, now in the denominator, I either need to write this as a product or write this as like an s minus a squared plus b squared type of thing. Okay, so if I can factor it in terms of real numbers, then I'll do that. If I can't, then I'll write it in this way, in the complete the square way. So if you complete the square, you get this. Okay, now if you could factor this, that plus sign would be a minus sign, so maybe just completing the square is kind of a nice way to do it anyway. And now this is where I messed up in the last problem. The part in the brackets here, this is equal to the Laplace transform. So the part in the brackets, not the e to the minus s part, but the part in the brackets is equal to the Laplace transform of e to the t sine of t. And so overall, x of t is equal to u1 of t times e to the t minus 1 times sine of t minus 1. And that is the final answer to this problem.